The broadcast is now starting. All attendees are in listen-only mode.
Welcome everyone to Continuous Delivery with Amazon Web Services with Stelligent CTO Paul Duvall. My name is Rob Daly and I'm a director here at Stelligent. Our bread and butter is continuous delivery. In addition to training and consulting to help others do it well, we actually can come in and set up your CD ecosystem for you, including tools, policies, governance, and best practices. Once established, we then transition your own people to take over and evolve it. We can do this through a public cloud provider such as AWS or by using your own data center resources. For more information on how Stelligent can help you, go to stelligent.com/solutions or contact any of us for more. We'll have some time at the end to do a little Q&A, but feel free to ask your questions at any point in time during the webinar by typing your question into the questions block of GoToWebinar. With the exception of Paul, all phone lines will be muted. So that's the way to do it. If we're unable to get to your question at the end, we'll get back to you in the next few days. Today's webinar is a part of Stelligent's monthly series of webinars on continuous delivery. Today, Paul will be providing an introduction to using Amazon Web Services for continuous delivery. In next month's webinar, which is scheduled for Tuesday, July 24th, the topic will be Test-Driven Infrastructure with Chef. You can sign up for this by going to stelligent.com/TDI. If you have other topics you'd like to hear related to continuous delivery or the cloud, just let us know. We're all ears. We'll be recording today's webinar and we'll provide a link for future reference. We'll also be sending you an email with links to the presentation files and various other resources after today's webinar. You can also join our LinkedIn group called Continuous Delivery in the Cloud. We've got 115 members and are growing strong, and we'll be updating it with useful content as we go. Please feel free to contribute to the conversation as well. A little bit about today's presenter, Paul Duvall. Paul is Stelligent's CTO. He's featured speaker at many leading software conferences. He has worked in virtually every role on software projects: developer, project manager, architect, and tester. He's the principal author of Continuous Integration, Improving Software Quality and Reducing Risk, which is a Jolt Award winner. He's also the author of Startup at Cloud, 33 Tips for Running Your Company Using Cloud-Based Software. Paul contributed to several other books and authored numerous articles published by IBM DeveloperWorks and DZone. Later this week, we expect either tomorrow or Friday, Pearson Education is going to be publishing a 4.5-hour video that Paul made early this spring, called DevOps in the Cloud. It walks viewers through each of the steps in setting up a continuous delivery platform in the cloud. Finally, if you want to learn more about Paul or Stelligent, you can follow Stelligent's blog at stelligent.com, where Paul and others at Stelligent cover everything from automation to continuous delivery and the cloud. You can also reach Paul on Twitter by using the handle @PaulDuvall or Stelligent by using the handle @Stelligent. Well, with that lengthy intro, I'm pleased to turn it over to Paul Duvall.
All right. Thanks a lot, Rob. So I want to start things off by giving a definition of continuous delivery. I went over this in the last webinar, but continuous delivery is the full automation of the build, deploy, test, and release processes so that software can be delivered to any environment, including production, in just one click or even automatically to specific environments. In today's webinar, I'll be describing some of the Amazon Web Services features that you can use in creating a continuous delivery platform. So in using continuous delivery, the entire team gets this quick automated feedback of the production readiness of a release candidate with every change to the version control system, be it the application code, the configuration, infrastructure, or the data. Because the software is always in this releasable state, the business chooses when to release and how often without being hindered by operational constraints. And the benefit is making these changes and releasing software is, in doing this, it's not this long, drawn out and error-prone process as it is with traditional methods. So teams can release software as often as they choose. So I'll be going over the basics of, as I mentioned, several of the services within AWS, which is the leading infrastructure as a service provider. So I'll go over using Amazon Web Services Management Console, which allows you to manage these the 20 plus services that are available through AWS. I'll also go over and how to interact with the Elastic Compute Cloud, the EC2 instances, which can be used to host servers and applications. I'll go over defining security groups, and if we have some time, I'll go over Elastic Load Balancing and auto scaling. Also discuss how you can manage your domains with a service called Route 53. And then we'll spend some time going over the simple storage service, or S3 for short, to upload and manage and store objects that you might use as part of your continuous delivery platform. And there's some other services that I'll cover briefly as well, but they won't be the focus of creating the CD platform. Now, there are 5 different ways that you can use most AWS services, from the management console, which I talked about, but you can also do it from the command line, from a RESTful service, from a software development kit like Ruby or Java, .NET, so forth, and from CloudFormation. And we'll go over CloudFormation in a bit as well. So with the cloud, you can you scale your infrastructure up and down on demand. You can get worldwide distribution of content. It's also employs a pay-per-use model. So you're only paying for what you're using. You're able to get a lower cost if used properly. You can create these scriptable infrastructures. I'll go over that a little bit today, but in the webinar on July 24th, I'll be going over test-driven infrastructures where everything's is scripted. But again, I'll spend some time on that today as well. And then finally, everything is an API in using Amazon Web Services or using the cloud. So everything can be called through a web service. So let's talk about each of these in a little bit more detail. So with scaling your infrastructure up and down on demand, these instances can be added to the infrastructure based on monitoring rules. So you can use a tool called auto scaling to do this, and you can do this via an API. And these instances can be distributed across a load balancer. So for instance, you might choose to parallelize your test across, say, 75 instances, and then terminate these instances once you're done, without being continually charged, by the way. So the great thing here is that you no longer need to procure your physical machines. That might take weeks, in some organizations it might take months or so. The second point is the worldwide distribution, is that you can actually design your architecture so that it's better performant based on the physical location of the users. So, say if you have most of your users in the Washington, D.C. area, you can actually set it up so through a tool called CloudFront that's geographically redundant, in the sense that depending on where you can actually do it based on there's a pattern that some of the AWS people talk about in terms of based on usage during the day. So you can actually change the location of the content that you're getting based on that. It's a pay-per-use model, in that you're only charged for the compute, storage, and the other resources that you actually use. So it's not a fixed capital purchase. It's essentially your operations expenditures versus capital expenditures. So once you terminate an instance or another resource, you're no longer charged for it. Right now, AWS charges, I think, around $0.015 per hour for T1 micro. And then it changes, it goes up based on the size of the instance. Talked about lower cost a bit, scriptable infrastructures that you can use tools like CloudFormation. You can create your own scriptable infrastructure with the cloud using tools like Puppet and Chef and things like that. And then, we covered that, everything's an API that you can get through a RESTful API. You can also go through an SDK as well, like Java or PHP. So let me talk about some of the AWS services that I'll be covering today when it comes to continuous delivery. The first one is CloudFormation. And CloudFormation enables you to create and delete related AWS resources together as a unit called a stack. And you can define the characteristics of a stack's parameters to the mappings, the resource properties, the output values using a template. And this template is a JSON compliant text file. And you can write your template from scratch, or you can actually start with one of the example templates that that AWS provides. So you can just go, if you just Google AWS CloudFormation templates, you'll be able to go to the location. You can also use a number of AWS's services with CloudFormation, including EC2 and RDS, and Route 53, and we'll see some examples of an actual script that you can actually get access to because it's all on GitHub. Next one is Route 53, which is a scalable domain system. And what you're able to do is you're able to programmatically assign the IP addresses and the load balancer endpoints to the internet domain of your choosing. So I do want to point out that Route 53 is not a domain registrar. You'll still use your domain registrar to create the unique domain name, but then after that, everything in terms of the DNS servers that your particular endpoint, your blog, your website, whatever, you can programmatically manage that through Route 53. As with the other AWS services, you can use Route 53 from the command line or through the API. We'll go over an example in a bit on using the management console or through the SDK. With identity and access management, you're able to manage the various resources through users, groups, and roles. And it's not for application, authentication authorization, but it's for access to, for instance, if you want to control access to, people only have access to an S3, bucket, or to S3 itself and nothing else within AWS. That's a way that you can do that. And we use that often with CloudFormation to, define a particular IAM, identity and access management user, IAM, that has access to specific resources. So with EC2 is provides access to these virtual instances, and you can run your operating system, your software, your configuration, all these on these instances, and it can all be done with a few clicks or a simple command from the command line, and you get access to all all your compute needs, really from data centers across the world. And it's set up in such a way you can have multiple availability zones within a particular geographical region. So if you're closer to the West Coast, you might put your EC2 instances out there across multiple availability zones, for redundancy and things like that. With Amazon Simple, and we're going to be, you'll see examples in how we often use EC2 is to, host when it comes to continuous delivery, might host your continuous integration server, and then, some of the target environments that you deploy to, test instances, and so on. With SimpleDB, this is a NoSQL database. And we typically use this for managing configuration and workflow information as you're going through the various stages within the delivery pipeline. And then finally, as far as the core services that we're focusing on today, is Amazon Simple Storage Service, which is essentially online storage. And you're able to get access to what are called buckets. And within these buckets, you can control access, and you could put configuration files that out there, or you could put images for your website, and basically anything that you'd use for storage is a way that you can use S3. So, not going to go over all these services, but some of the services I talked about. CloudFront, which is the global CDN, the content delivery network, which gives you access to, in particular, you can do streaming data, but you can do static data as well. And what a lot of people will use that for is that they want to have static images, and they want to serve that up so that the performance, when someone goes to a website, it's a lot more quick. There's also DynamoDB, which is it's a scalable NoSQL data store. And so there's kind of different use cases for SimpleDB versus DynamoDB. But basically the way you can look at it is one feature is that I believe there's it's either megabyte or or gigabyte limit on SimpleDB. There's a limit on SimpleDB where theoretically there's no limit on the amount of data that you can put through DynamoDB. Elastic MapReduce is a managed Hadoop framework. So if you're dealing with big data and things like that, it manages all the kind of the back end. You don't have to deal with the hardware and so forth. You just deal with it through a service. So if you're used to using Hadoop, but you don't want to set up and manage, probably more importantly, all the servers, you can use Elastic MapReduce or EMR. Elastic Cache uses Memcache, but again, another service-based, caching mechanism that you can use where you don't need to manage your Memcache servers. RDS is a managed relational database service. I have an example here, which is MySQL, but it also supports Oracle as well. But it's for relational database management. So if you're not using NoSQL and you're using a traditional RDBMS, it will manage you can set it up for data replication and the management of the servers as well. There's an email sending service, SES, simple email service. SNS is a notification service where what's interesting there is you can actually integrate that with things like auto scaling. So you could set up a rule that says, the performance of this particular instance is over 60%, or the CPU or whatever you set up in terms of your roles, and you can integrate that with CloudWatch and auto scaling, and then SNS. You can have it either send you an email, or what's really nice is you can actually perform a particular action based on that. And so, for instance, you can set it up where if it goes over a certain threshold, then you can add more instances to your cluster, so that the performance for the users is better. Simple queue service is a message queue service. A lot of these are services that you might normally use using like ActiveMQ or RabbitMQ or so forth. But the difference here is that it's all managed for you. There's a storage gateway. There's an interesting service, especially when it comes to continuous delivery and deployment and so forth, is SWF. It's a relatively new tool called Simple Workflow Service. But we won't be going over that in detail, but that's just another one to kind of keep your eyes out for. And then the virtual private cloud, which is VPC, allows you to isolate cloud components. Okay, so you probably have seen, or not just, you probably have experienced if you've been on, in particular, a larger project, but even on smaller projects, this occurs as well. You got the kind of the DevOps chasm, right? So you have the different motivations of the various organizations and people. On the dev side, you have the motivation. Usually, what the business is asking for is more features. I could probably say features here, and stability on the right side. But features, the deadline, marketing. That there's different motivations, and the goal there is usually to get software out as quickly as possible. And then on the other side with operations is usually the goal is to make sure that once that software is out there, that there's never any issues in production. So these are really competing motivations, and usually there's a chasm. There's a divide between these organizations, and kind of in terms of things like continuous delivery. With continuous delivery, as I mentioned, it's you're automating implementation of your build, test, deploy, and release process, and you're setting it up in such a way where the software is always ready to release, rather than what's typically occurs is regular intervals, like every month you might release the software, every it's a set date every quarter, or maybe it's just whenever you can get it out, because it might take weeks or months to kind of push things through. With continuous delivery, it's always ready to release. So it's no longer is it really how long it takes it's how long it takes the developers to it's basically if they have the latest feature, operations, it's no longer an operational constraint, right? So really, at its heart, the motivation leading to this DevOps movement is the frustration in releasing software. So, um, these two teams, they must collaborate, but they have these competing motivations. So, one of the goals is to work in more of a collaborative fashion, and by doing continuous delivery, you really have to. And there's this kind of sort of new breed of a DevOps engineer, if you will, that's emerging that takes the best of these both disciplines and combines them onto teams. And this is also manifesting in the rise of cross-functional engineers who are experienced in development, configuration management, database testing, infrastructure. But what's most likely is that the difference is that you have more of a kind of a collective ownership, and that anyone is able to potentially make a change. But it's more importantly, it's all part of one pipeline. So you can still have the people that may have more expertise on the operations side, but they're also incorporating things like test driven into the creation of their infrastructure and scripting their infrastructures. And the developers are thinking about things like, well, how's this going to work in production, not just how does it work on my machine. I went over this briefly in the last webinar, but so I'll just go over it very quickly here. But this is the steps that we use to get to continuous delivery. And I wanted to talk about, how this, and then we can talk about how it works in the context of, a cloud environment or Amazon Web Services. But, the first is, if you think about anything that you might do, so say the deployment of a system where at a really, simple level, let's say you're going to stop your Tomcat server, you're going to apply a particular change to it. You're going to push the war file out there, and then maybe make some configuration changes, and then you're going to start the server back up. So you're going to document that process and what it takes to do that. That's usually how it works. But the difference is you're going to be writing in such a way where you can automate that implementation. So next one is that you write a test for it. So once you've actually documented, and then you write a test for it that verifies the behavior that you expect. Then you write a script for it, and so you're going to automate. And you get it down to a single command. So you have a lot of fine grain, commands, but you write it in such a way where you get it down to kind of more of a coarse grain, down to a single command. And then once you have your tests and you have your scripts, then you make sure that you version all your scripts. At that point, you should be able to get rid of the documentation. The documentation is more, allows you to get to this scripted, tested, and version approach. What's this version? That's your canonical system and environment. And then lastly is once you have it all down to one command, you can run it headless with every change. And so when you think about, not just your application code, but your infrastructure, your data, your configuration, and your application code, that you would go through a very similar process in applying, this kind of heuristic to getting it to a continuous process. So continuous integration is a part of, it's a kind of an enabler of continuous delivery. And in this context, you have, the various specialists, and it could be more of a, as I mentioned before, more of a cross-functional engineer. And they might be checking in code to your version control repository. And then you have a CI server that's polling, the version control system. And then it creates environments and deploys out to these environments, builds the software, tests it, and so on. But the continuous process, the continuous integration process, an enabler for all these different types of people that are going to be making changes, and also all the different types of scripts that you might be applying to it. And here's an example of a infrastructure, a continuous integration infrastructure, and the kind of the overall architecture. You can see that it's using some of these various cloud components here. So you have, let's say you have a Jenkins CI server on an EC2 instance, and then it calls, various scripts. I have an example of calling a Ruby script. It might put it in a queue. It might be polling the GitHub repo. these are just examples, by the way, in terms of all the different, Jenkins and GitHub. These are just, you could use, here you could use Perforce at TFS and Subversion, so forth. Here you could use, TeamCity, Bamboo, Anthill Pro, whatever. So you could define a CloudFormation template. And again, that's the JSON based. If you haven't seen it before, we'll go over in a bit. But let's say I have a Jenkins.template file, and it describes all these various resources that I want to configure. And then I make it available once and it installs all these various components. Let's say it installs the Tomcat server, installs the JDK, installs it copies over the Jenkins WAR file. It sets up the connection between Jenkins and GitHub. It establishes whatever the S3 buckets are, the configuration for the workflow of the delivery pipeline. And then it might use this target template, which is a template gets run from the Jenkins CI server once it's set up, and it might deploy or create these environments and also deploy out to these environments as well. So of course, this is just one basic example. You could have a cluster of Jenkins servers. And all the various tools that might change in the overall definition of this infrastructure. So we'll see some examples in a moment. All right, so I wanted to go over those various 6 or so services of the 20 plus services that are part of Amazon Web Services, and then I'll go over some examples of how to use that. But the first one is EC2 that provides the compute needs, and so you can launch and terminate an instance. And typically what we use the EC2 instances for are things like running builds and running deployments and hosting the CI server. You can define your virtual firewall through security groups. You can host your operating systems such as Linux and Windows. If you're running your builds, all the various types of build scripts that you might be running. You're running deployments. Tools like Capistrano or Control Tier, so forth. Hosting your CI server, you'll see an example of that. We define the creation of the infrastructure using CloudFormation and all the various resources that you need, not just the EC2 instance, but also S3 and things like that. But where you can host your CI server on an EC2 instance, and then all the kind of the setup as well. So actually, I'll go over the EC2 demo in a moment. I'm going to do them all at one time, but I'll create a security group. I'll launch a new instance from the AWS Management Console. I'll terminate an instance. I'll create a key pair, create an elastic IP, and so on. But this is the dashboard for the EC2 console. So these are various instances, and we'll go over that. Route 53, I'll go over some examples of that, but it's a highly available and scalable domain system, API driven, translates these endpoints, these IP addresses into human readable names, and you can do that through the console, SDK, and see an example in CloudFormation as well. S3, you can store your configuration files. Talked about images, but you can back up log files. You can define these globally unique buckets, and you can put the various files that you might be using, control access to them as well. SimpleDB, the NoSQL database, it manages all the provisioning, the hardware stuff. You don't have to deal with any of that. It's just a service that provides like key value pair kind of thing. We use it to store configuration values that we might use. Then access management, IAM. Talked about this briefly, but you can define users and groups and roles for access to AWS resources. And just to emphasize that this is not application authentication. This is only access to EC2 resources, to AWS resources. You can create these users using scripts as well. So you can do it through CloudFormation as an example. And then finally, CloudFormation. It's a scripted infrastructure. In the webinar on July 24th, we'll go over a lot more detail. You'll see example in a bit, but a lot more detail of using CloudFormation, but also tools like Chef as well. So that's specifically around Chef. We'll probably talk about Puppet as well. All right, so let's go. I'll go through a demo, and I'm going to DevOps Cloud, and that's actually it's the website for the Rob mentioned the video that's coming out later this week. This website is available to anyone. You don't have to pay for access to this, so you can just go to devopscloud.com and you can go through the same lessons that anyone that gets the video or watches the video in that 4.5 hour video, you can go through the same lessons. Of course, it's probably easier as you watch the video, but this is also accessible to you as well. So what I was going to do is just go through some of these various services that make up AWS. So the first thing we'll do is we'll go to the AWS Management Console. And I'll go to EC2. So this is the Elastic Compute Cloud. You can see here, I got 3 instances that are running. I got security groups I can define. So there's a default security group. One of the best practices really is to limit access, or what I tend to do is I never put anything in the default security group. That way I know, because by default, of course, it goes to the default security group. But I want to make sure that I knowingly give access, because this is as I talked about before, this is essentially it's a virtual firewall. It gives you you can define inbound and access, but you can also define across like one group within the AWS infrastructure. You can define one group that has access to another group. So you can define it within the infrastructure, but you can also define internet-based access as well. So I can create a new security group and call it SSH. Hit create, and then I can go to the inbound. I can say 22. For the SSH port, I can define this is a CIDR notation. And what this means when you see the 00 like this is that you can look up CIDR notation like on Wiki, but for more details. But basically what this means is that anyone on the internet has access to this secure. If you have this security group and you assign this security group to like an EC2 instance, anyone would have access to the instance through port 22, but they would have to have a private key. So it's not like just anyone, but you can either further define this. You can say, I want it for a specific IP address, right? So you can define that with this the CIDR notation. And then, so I'll just keep it here. 00, I click add rule. I apply the rule changes. And now I have a security group, but it doesn't do anything because I actually have to go to an instance. And so you see I'm going through this through the management console. But like I said, you can go through this through an API of RESTful API. You can go through an SDK, and then just kind of straight up command line as well. So for instance, I can go to this and I can sign a particular security group to it on the definition. So let's say I launch a new instance. So that's the difference here, right? When in a traditional organization, you have a data center, and you might go through that month-long procurement process or fill out a form and wait for someone to get back to you. Have the multiple email back and forth, the multiple meetings just to get an instance, right? And so the difference here is you select the button, right? So click continue. And then, so here you see the security group that I just created. So I can just click on, what that means is that this instance will only have access, will only have external access through that 22 port. And then furthermore, you have to have a private key. And I already defined a private key. I just went through that step, but I'd already defined a private key. And then, so I have that on my computer, and I can use that to SSH into the instance. So, yeah, I can. So this is running, so I can just select this. So I can change the permissions on the instance, and then I would SSH into it. So that's the basics of launching the instance. I can also terminate the instance as well. And now you see it's shutting down. What that also means is that I'm no longer charged for that instance. Of course, your mind can wander and say, well, what if I want to set up a bunch of instances? I talked about the example of the 75 instances. Well, you can, go to, you can interface with the EC2 API in some, Java program or some PHP program that you've written. And you can do that. You can launch these 75 instances. You could run them for 30 minutes, and then you could go in and have it automatically terminate those instances. This is all, because you have this programmatic access, there's all these different options that are available to you, with and using this kind of approach. Okay, so let's look at now Route 53. So Route 53, I can create what's known as a hosted zone. So if I have access to, I can create a hosted zone. Of course, I don't own CNN.com, but you get the point that you can define the domain that you have access to, and once you get access to, you'll get a delegation set. I can use that delegation set, and I can go into I can go into record sets, and I can see I got I can create A name records, I can create C name records, and basically all you're using a domain registrar for is a domain registration. You can use, a lot of people have separate DNS servers. The difference here is that you're able to programmatically change this, and so it really lends you a lot of power. Where, and when we go over CloudFormation, you'll see a kind of a brief example of that you can define, a lot of this, within a script, and you can say, well, I have access to DevOpsCloud.com, which, by the way, this is hosted, and I'll go over that in actually a moment. But it's hosted on S3. So let's take a look at S3. So you can see here, I defined DevOps Cloud. I own that domain, and then I uploaded the various HTML files, and then by default they're always private, but then I can make them public. Right, so they're all. They were all public anyway, but I just want to kind of go through that process, and then I can, this is not the only way, of course, of using S3, because it's online storage. So however you would use online storage, as you know, a lot of vendors out there are using S3, Dropbox, and there's lots of various vendors out there that are using it behind the scenes. You don't even know about it. So I have the website, and then I defined in my CNAME record, that this is goes to DevOps Cloud, but it also goes to this location as well. So that under the hood, that's where it actually is going. But then I used Route 53, and I defined a CNAME record for www, DevOpsCloud.com, And so all this is actually running in S3, and then uses Route 53 to tie it back to this domain. So again, a lot of power in this. So we looked at security groups. We looked at EC2. We talked briefly about ELB, but that's within EC2, elastic load balancing. It allows you to distribute load across multiple instances. Auto scaling, you can configure that with CloudWatch. And so based on certain thresholds, if it is going over a certain performance threshold, such as CPU or so forth, you can have it scale out your infrastructure, which is really nice, right? Because you're only paying for what you're actually using. So you can start with one, and you can scale it up to how many you want based on the load. So if you get a lot of load in your organization around say November, December timeframe, you're only going to pay for it as you're using it, and you can set it up based on rules that if it goes over this threshold, boom, you got these other instances that are running, right? So we went over Route 53, S3, and this will go over CloudFormation. So we can take a look at this. This is a Jenkins template, and you can see everything here is scripted. And this is the JSON notation. So there's 6 kind of key components within a CloudFormation template. Really, description and AWS template format version. Those are 2 of them. So it's really kind of 4. Resources, which is the second one we'll go over, is the only one that's required though. But the first one is parameters. So for instance, let me show you. If I go into CloudFormation and I create a new stack, and I upload a template, and so you see the private bucket, public key name, so forth. That's the same thing you see here. So as you're going through this wizard, you're defining this in the template, and then you just consume that template as a part of the process. And of course, I'm going through a wizard. As you might imagine, we could run this whole thing from the command line. And in fact, we do that. So, this particular template ends up creating this dashboard that you see here. So I have a Jenkins CI server. This is all defined using this template. But when you go into some of the builds that are defined here, like build deployed environment, it will actually call, in this case with the environment job, it's going to execute from the command line a CloudFormation, creation of a CloudFormation stack. So even though you saw the example of me going through the wizard, you can also go through the command line. You can go through the API, right? It's all the same. The second one is mappings, and basically this allows you to kind of do a case statement in a way. And you can say, well, based on this architecture, this is the type of architecture, the type of AMI, which is, if you think about like just a machine image, it's called an Amazon machine image. And then you have the various resources that you can define. I talked about the IAM user, the identity and access management user. You can create that on the fly. You can see you're creating the couple queues on the fly as well. Some policies that apply to the access to the S3 bucket. On the web, the actual EC2 instance. So you saw where I was going over all the step-by-step wizard-based process. With CloudFormation, I can define all this in the script. And the nice thing you can do is you get it down to one single command, or you can run it in a headless. You can run a headless mode where it runs that one single command, and it's doing all this for you. Of course, this relies on that you're only using Amazon Web Services resources, but you can also do the exact same thing in Puppet and Chef as well. So you can actually, we typically set it up in such a way in Amazon Web Services infrastructures where we use CloudFormation for the AWS specific setup, and then for the instance configuration setup that is not really relying on the AWS resources, then we'll use Puppet or Chef or whatever under the hood. But this example is all just straight up CloudFormation. You can see that I've got, I'm just downloading from a Yum repository. So I download Java, Tomcat, Git, all these various components, And again, the nice thing is it's all scripted. So, that's essentially your documentation, because it's actually doing which you've specified in the template itself. But also, it, that it can incorporate into all these various systems, such as continuous integration systems. So going down, again, I'll go over this more detail in the next webinar, but you can see that you're defining various files and the permissions for those files, and getting like certain Jenkins plugins, and applying permissions and installing Tomcat, giving security access, and you can see, so you're not clicking through the same thing, because if you write some documentation, and invariably people mess up either the writing of the documentation or the keeping up with the documentation, or people just reading the documentation incorrectly. But you can't mess this up. It's always going to go through the exact same process every single time. It's not that, of course, errors can happen because you have variable, I assume everything, will go wrong eventually. So, but the point is, it's always going to run through this script. And then lastly, there's the outputs. And the outputs are pretty nice because, you can go to, for instance, after it gets created. So, I go back to CloudFormation. I can select, I can select outputs. And then, I can see that here's the DNS value, or, I go here and I want to load up the link to the CI server that got created, and so forth. So, so that's pretty much it for some of the demo. But you can look at, you can go through this whole exercise. As I mentioned, it's all freely available on DevOpsCloud.com. So I think that's it, and I guess I will turn it back to Rob.
Thanks, Paul. I don't know if you could see if we got any questions or not. We're going to go ahead and we've got a few minutes to do some Q&A. And as I mentioned before, if we do have more questions that we can actually get to right now, we'll get back to you in a few days.
Okay.
I'll let you read them if you can.
Yeah. All right. I'm looking through some of the questions now. We had a question about CIDR notation. That's CIDR. And I forget what that stands for, but domain routing, something like that. But yeah, you can look that up. Wikipedia has a great article, last I checked, on describing CIDR notation, how you can define it that restricts access to certain
classless interdomain
routing. That's very important for us to know. Okay. Classless interdomain routing. Okay. Let's see. Another question is, because you can spawn so many instances concurrently, can I expect to see my overnight builds and tests get reduced in their total time? Yes, absolutely. So one of the great things is that, and what we typically use as kind of a metric is your longest running test. So let's say your longest running test is 5 minutes long. Does a bunch of stuff or whatever, some acceptance tests, who knows. And that should be the longest running time of your entire build and deployment process, or your entire testing process, right? So because you're able to run them concurrently, so you can scale it up so that you can run this does depend upon that you have your test architecture set up in such a way where you can run them in an isolated way and then kind of group it at the end to get the overall results. But if you have, several thousand tests, there's, arguably you can set up so that you can run multiple instances and run those tests. So Generally speaking, I mean, you might set it up so that you might have a few hundred tests that are running on one instance, and it might take the time of that particular instance to run through those tests. So. How can I use DevOps Cloud as a training site? Can I get training on it? Yeah, so we do provide training. Rob can probably talk a little bit more about that, but we do provide a 3-day training. But you can use it right now. You can just go through I would highly recommend. You really have to go through it from the beginning for the most part. There's certain exceptions to that, but in terms of setting up the infrastructure. What we found is generally if you go through all the lessons, it's about $10 in AWS services for you because you use your own AWS account. But you can also just read through it as well, and you can probably get a lot. There's links and a lot of knowledge just from that. Someone just said ignore the earlier question about cider. I guess they saw it in the Jenkins template, but yeah, at least we now know what it stands for. What is the LOE to move a single simple Java app to the cloud? So there's a number of, if it's a single simple, I guess it depends on what the definition simple is, but it depends on really, you could have a single simple one that still uses, say, multiple instances, your database. Really, what we recommend is that you go through an inventory. You could either forklift it, meaning you take your existing application and just move it over to the cloud without any changes, or you can start to leverage certain resources of the cloud as well. So, for instance, if you want to go with a NoSQL data store like DynamoDB, then you might need to change some of your architecture. What you could do is you could forklift it and then kind of incrementally make those changes and kind of get some of the advantages that you can get with like this infinite scaling model that you have with the cloud. But it is one of those. Of course, it's one of those depends kind of questions. It depends on how many currently how many instances you have running. It depends on your database, whether it's a shared database. I guess when the question is simple single, I'm assuming that everything's running on one instance or something like that. So, I mean, I would imagine something like that could be forklifted in less than a week. But if you want to start taking advantage of other things, then you might add some more time. But the reason you would do that is because you would maybe get away from the management of the database itself, as an example, or you might want to take advantage of Route 53. You might want to script your infrastructure, but the whole idea is that you're going to get more benefit in going with that approach. Let's see. What sorts of things are different when a local private CD crew moves to the cloud? More or less people, less insight. So I guess I'll answer the last question first. Not less insight. I would say, definitely you can get as much insight as you want, especially with infrastructure as a service. We didn't talk about platform as a service all that much, but with platform as a service, it's sort of abstracted away from you. And with that, yeah, you probably do get less insight in them, but that's sort of it's by design. It's, tools like Heroku and Google App Engine and things like that. And then there's also sort of a mix. Like if you use something like Elastic Beanstalk, it's not really a PaaS service, but it provides a lot of the Elastic Beanstalk is a part of Amazon Web Services. But it provides like the Tomcat container for you. It provides all the SNS setup, all this stuff that you saw like in the CloudFormation template. All that stuff's defined for you. With Elastic Beanstalk, and they support PHP and Java. So there's sort of a middle ground there because you still get access to everything in the infrastructure. You see how it's all set up, but then it's kind of some of it's configured and then also managed for you. Let's see, more or less people. I think I think the key thing there is with more or less people is that you can get less people if you look at it from the perspective of, I'm going to, apply those kind of 5 steps. I'm going to document, I'm going to test, I'm going to script, I'm going to version it, I'm going to make it continuous. It's the same even in your own local, your private data center. But when you move to the cloud, since everything is now accessible through a service, it makes it a lot easier. You don't have a lot of the gatekeepers, and through tools, or in some cases through people. That's what some development organizations might find out. At the same time, that said, is that you still want to have the same kind of operational policies and so forth, in terms of defining the infrastructure, not in terms of some of the artificial gatekeepers, because the reason that's usually occurring is because of scarcity, because no one wants to touch that instance because it was configured just perfectly. Well, in this case, once you script everything in the cloud-based infrastructure, you get away from that. And one of the patterns that we really advocate is something called transient instances, or ephemeral instances, where you should always assume that all your instances are going to go away, and therefore you need to script it and test it and version it, right? Like I went over before. So I don't know how we are on time, but let's see. Yeah, we're getting a few. Yeah, we're about 3 minutes to go. So I'll turn it over. Oh, sorry. I'll turn it over to Rob.
Thanks, Paul. Okay, it looks like we only had like one more question we didn't get to, but we'll try that another time. So if you're thinking of employing CD and would like to minimize the risk of doing so, we're pleased to chat with you about your concerns, issues, or goals. We actually offer a small service to help you get started in the right direction called Discovery. You might have, if you were here in the previous webinar, you might have heard about that. You can learn more about it from our website, stelligent.com. I hope you've enjoyed today's webinar, and we look forward to next month's webinar, seeing you again. Be sure to tell your friends.